Welcome to On-Site Insights, a series of podcasts by On-Site Ventures about deep tech and the people behind it. We invest in the next groundbreaking idea.
Welcome everybody to the second episode of On-Site Insights. We have Daniel Volz here with us. He's co-founder and CEO of Kipu Quantum. And I find it quite interesting, Daniel, you have a background in chemistry. How did you find your way into the quantum space?
That's quite interesting, actually. So, hi everybody, by the way, and many thanks, Yasmin and the On-Site team for having me today. I'm a chemist, and when I started chemistry, I think I read very early about quantum computing in my studies as an obscure research topic, and I didn't understand it at the very beginning why it actually should be relevant. So this was, around 2006 or so, 2007. So I looked at it. I thought, okay, sounds very complicated, and I kind of dismissed it initially. And it was years later when I was working at a startup company that was founded by one of my co-founders of Kipu, Tobias, that I slowly began to understand why quantum could be relevant. We were doing material development for optoelectronic applications, organic semiconductors for display applications, for instance. And we have been using a lot of classical computing back then, which was partially helpful. So it was a nice tool to allow us to develop materials with much fewer experimental testing required. But we also learned that it's actually impossible to reach a certain accuracy level for chemistry modeling. And so we literally went to the very frontier of what's possible with conventional supercomputing, and there was still a lot to be desired. And then I reinvestigated or revisited quantum computing and found, okay, it's useful after all if it actually reaches a maturity. So this was that story, essentially.
You have already mentioned Tobias. Can you tell us a little bit more about the founding team and what talent everyone brings to the table?
Yeah, happy to do so. So the founder team of Kipu is essentially Tobias Grab, also a chemist actually, Enrique Solano, a physicist and former professor of quantum physics, and myself, Daniel. And I think we have a kind of clear-cut split between responsibilities in the founder team. So Tobias already built a startup. He grew this to a size that is still larger than where Kipu is today. So I think when Tobias left his post as CEO of Sonora, the company was in the order of 80 people, essentially. So more or less twice the size of Kipu. And he has a lot of experience in all matters related to company building, operational aspects. He's also very strong in coaching people. And I think something that is similar to my first time in the startup as a young scientist at Kipu is that a lot of the leadership positions in our company by default have to be played by scientists with very little leadership experience prior to that. So I think a lot of the work that he's doing is about coaching young scientists into strong leaders to bring forward quantum advantage at Kipu. That's Tobias essentially in a nutshell. Enrique, or Kike as his friends call him, is the scientific mastermind behind what we are commercializing. So he spent more than 20 years in academia, had various professorships in Munich, in Spain, Bilbao, as well as Shanghai, China, before switching to the dark side of industry. And I would say it's fair to say that all of our technology ultimately boils down to his foundational ideas. And I play the role of a generalist with a deep understanding of the end user's application side. So I started talking about my career in the startup world, but after that I actually spent several years at McKinsey, where we back then started consulting large corporates in chemistry, but also in other verticals in quantum computing. And I've also held a leadership role at BASF and was tasked to formulate a quantum computing strategy and lead that effort by the board of directors for some time. So I know how quantum computing is thought about on the end user side and try to bring this to our organization make sure that Enrique's brilliant technology is turned into useful and appreciated products, essentially.
Yeah, great stories, great team. As far as I know you, you're quite ambitious. When you started your company, what was your fundraising strategy and where do you stand today?
So from a fundraising strategy, I started, and I think this is still a bias that I have. I'm looking at the quantum space still through the eyes of an end user. And when I was at BASF, I think I saw a lot of ambitious companies that were deeply driven by technology, but unfortunately, I also saw some companies trying to treat quantum as a hype topic. And, I'm not saying that they were trying to fraud BASF, but there are certainly snake oil salesmen around. And I wanted to make sure that Kipu is never considered as one of those companies. So for us, it was very important to get validated investors on our cap table from the very beginning to assure that there is somebody that can actually vet and attest to the technological soundness of what we are doing. And from that perspective, it was very clear that that Quantum Nation would need to become one of our investors. Quantum Nation is one of the leading quantum computing sector funds. I think the largest, not necessarily by deployed capital, but certainly by number of deals made. And they are led by quantum physicists and are all around extremely good in figuring out where there is actual merit to a scientific idea versus just fluff, essentially. And for our pre-seed round, we built essentially a team around, built our cap table around that, supported by First Momentum Ventures, which is an investor based out of Karlsruhe with very strong ties to KIT. So KIT is also my own alma mater. And we also added Entrada Ventures to our cap table. Entrada is based in the United States. I would say deep tech fund with some arms towards generalism also. And I think they bring something interesting to the table because they have a very good network in the US investor scene. And I think for us, right now, we are still in a phase where European investors can actually contribute in a meaningful way to our success. But I think in 1 or 2 rounds from now, this may change. So I think it was very important to also having that essentially. And, the pre-seed round themed around validating our technology was a nice starting point, and we've essentially managed to build the company around that momentum and started convincing paying customers to work with us, and then decided to do our seed round last year essentially balancing now the deep tech world together with more generalist funds. So we've managed to convince all of our existing pre-seed investors to contribute, but also added generalist investors like HV Capital, which is perhaps the leading generalist fund out of Germany, certainly in the top 3 in all over Europe, as well as deep tech funds that have very strong connections to the tech ecosystem and can bring beyond money also expertise and network to the table. And I count On-Site Ventures, for instance, along those investors, but also Worth Capital as well as Kai Ventures out of Switzerland.
Yeah, you were talking about your corporate experience before, and that quantum is really one space that is not very well understood by every shareholder and stakeholder around. So if I look at your webpage, you're saying you're working on application and hardware-specific quantum algorithms packaged into software products.
Yeah.
Can you describe what this really means if you work with your customer in practice?
Mm-hmm. Yeah, happy to do so. So I think maybe this answer has 2 parts. First, why even bother with something like application and hardware-specific algorithms, which is admittedly quite a mouthful. And then maybe second, how this is brought to life with large organizations, essentially. So I think there's a strong necessity to moving beyond hardware agnostic, generalizable quantum algorithms, at least in the short term. And I think this necessity comes from the fact that we are still in the onset phase of quantum computing. So if you look at the machines, some of them look very sleek and professional, and I don't know, there are some rack-mountable quantum computing devices out there, but there are also quantum computers, and I think even some of the stronger ones that more look like lab experiments, actually. When I was studying chemistry at KIT, I've seen a lot of laser tables and photonic experiments in the day, and I think some of the quantum computers actually look more like this than conventional HPC architectures. And I guess this also is related to the state of the technology. So the fact that we are early and the hardware is still small and not super powerful means that we essentially need to find ways to squeeze out all of the performance out of these machines as possible. So from that perspective, we at Kipu believe that this necessitates tailoring algorithms very strongly against the various hardware to assure that we are not wasting anything of the potential. And also, we also believe that it helps to tailoring these algorithms against the applications themselves. So we have very specific algorithms that are therefore significantly more powerful and have the power to extract much more potential out of the quantum machines. But of course, they are more specific than that. But we think that it's worth it because, quantum computing is not yet useful. We believe that Kipu is going to be the catalyst to making them useful. And being more specific is next to further improvement in the hardware, I think, the way to go here. Now, how does this look like when bringing it to life with customers? So at this point, we are especially focusing on organizations that are already on a quantum journey. And I think this can be large organizations that have already significant teams set up. There are some organizations, for example, like JP Morgan, that have actually more than 20 quantum physicists on staff exploring financial applications based on quantum computing, and also substantial budgets. Of course, the teams are not always that large, but we typically work with organizations that already have these teams, so that the POC work we are doing is kind of technical at this point. We are working together with experts typically that can assess that our algorithms actually bring something valuable to the table. And it's really a co-creation model in which we are working very closely together to assure that our customers have first access to useful quantum computing by building something tailored for them. Of course, in terms of productization, the idea is to package our algorithms ultimately in scalable software products. So once we found the first application where quantum computing can actually be applied for useful applications, the idea is to put this on the product platform that we are currently building, to then grant access to a wider community of other users for these use cases. This is kind of the model that we are thinking about. We've also recently broadened our customer activities towards quantum users that know that quantum is potentially interesting for them, but are still earlier in their journey, because we believe that now the advantages of quantum computing are still not here, but will be here quite soon. So I think it's now also worth for less experienced organizations in the quantum sphere to start getting their feet wet and essentially setting themselves up to be prepared once quantum computing becomes useful.
I want to bring up a second example. You have also a DLR project on battery material simulations. Explain what your goals are here in this project as a partner in the consortium.
Yeah, happy to do so. So I think, I'm a chemist. I did not do battery chemistry in my own research. It was more in the display chemical space. But I think there are some similarities in the sense that we are looking at electrochemical processes. Fundamentally, it's material science. So there are some wrinkles in that go beyond the sheer materials, because they also need to perform as an assembly, essentially, as a real product setup. And of course, electric vehicles is a huge market. And I think the hope is that quantum computers can actually contribute to the material development in that space, which is may be comparable actually with the kind of state of affairs in what I was doing in my first step in my career at Sonora in the organic semiconductor space. So typically batteries are built using several materials sandwiched together. You of course need to make a battery to really know if a material, a new material or an improved material is actually performing as expected. And then really you need to invest a lot of effort to characterizing and testing hypotheses essentially in the battery space. And the hope is that quantum computing ultimately reaching a point where it's possible to do much more robust material modeling to assure that you don't need to do as many experiments. And ultimately, essentially accelerating R&D cycles to make sure that we get access, or humanity gets access to battery materials and ultimately electric vehicle batteries that have significantly better properties, factors like weight, stability, absence of metals like nickel or cobalt, charging behavior, capacity, and so on. And on Project BASIC, we are one of several contributors and essentially are developing a software-based module that ultimately works along the same lines of our general claim. So we are trying to figure out ways to use smaller quantum processors to do these kind of calculations on near-term quantum processors, which is, I think, interesting and also valid because it's, I would say electric vehicle batteries is perhaps one of the big 5 or big 10 open questions in the overall field of chemistry. It has tremendous impact, and I'm very happy and grateful that we are working together with the DLR team to exploring how quantum computing can actually help here. And of course, also makes me very proud to see that our algorithmic capabilities are essentially involved into software products directly that are helpful to making new battery materials.
Yeah, we at OnSite, we are very much looking forward to seeing all these great advancements, and we always say that we invest in exponential technologies. Do you agree that quantum is just at the knee of the curve to massive future growth?
Quantum computing, I think, fits the OnSite hypothesis to a T. If you think about it, even the exponential part is baked into quantum physics because one of the effects of quantum computers is that things essentially improve exponentially, at least in theory, if you add perfect qubits. So each added qubit essentially doubles performance, which leads to exponential scaling behavior of quantum technology. So that's a very, very quick fit, I would say. I would also say, looking at quantum as a technology, we are actually quite close to doing meaningful things. Again, I always make the caveat that it has not been achieved yet. I want to differentiate Kipu and myself also from some of the snake oil salesmen that are out there actually. But I would say we are very close in quantum computing. There's maybe incremental improvement required on the hardware side. And I'm not saying that incremental improvement will lead to a miracle machine that can fix climate change, cure cancer, and optimize our supply chains. But I do believe that we are maybe one incremental hardware improvement step or two away from quantum computers starting to solve meaningful problems. And I think that is perhaps the definition of being at the onset of this need, because once this has been demonstrated for the first time, I think, quantum is oftentimes compared to AI, but I think it's maybe going to be similar to this ChatGPT moment in generative AI, where there was a lot of talk for years and perhaps decades about the validity of the technology, and then suddenly a valid, useful application emerges, and then the technology really sets off. And I think this is imminent with quantum computing. It's not going to be another decade, nor is it going to be another half decade, to be more precise. And I'm very happy that Kipu, together with our partners in the hardware ecosystem, is very close and at the frontier of this development.
And who in the hardware ecosystem do you work with, or which platforms do you personally follow the most?
Mm-hmm. So from my perspective, Kipu, the hardware specificity of our story comes to life by two means. So we can, of course, access and run our algorithms with everything that is on the cloud. But I believe that there's a lot of value in actually partnering up with hardware vendors to assure that we are kind of directly joining forces with the people that are running these hardware machines. And so far, we have 3 very bespoke partnerships that are deep in co-development. We are working together with IBM, which is one of the large corporate players, essentially. We are working together with QEra, which is one of the leading US startups out of Boston. And we are working together with Pascal, which is one of the best funded quantum startups in Europe with headquarters in France, and essentially ties to Professor Alain Aspect, a Nobel Prize winner in physics. So these are 3 very strong organizations that we like to work with. I think generally speaking, I would like to add ion traps as a hardware paradigm to that list, which we are currently mainly accessing through cloud access. We have companies like AQT out of Austria, IonQ and out of the US, and Continuum with headquarters in the UK as well as US in the ion trap space. And of course, the quantum annealing technology that has been pioneered by a company named D-Wave out of Canada is also on that list of technologies that we are very, very much focusing on. By the way, this list is maybe shorter than many expect, but of course we are not excluding additions of any other hardware vendors to that space. So it has been my experience that it's still a neck-to-neck race in the quantum technology. And when I was doing my first steps into the quantum domain which was around 2017 actually, when I was at McKinsey, I was doing a lengthy analysis on the different hardware setups, and neutral atoms was maybe the new kid on the block. Certainly not one of the highlight players. And right now, I'm leading a company that has actually 2 partnerships with neutral atom players. And of course, this just shows that things can change very quickly. And depending on what the photonics players like Xanadu and PsiQuantum and Orca Computing are delivering, or what spin qubit-based companies are doing like Intel, or NV center-based companies like Quantum Brilliance, the list that I just gave may change also in the future.
And all of these companies are, of course, growing and they need talent. You have raised 10.5 million quite recently. You're also hiring. Did you feel that there is a shortage of talent also for Kipu Quantum?
So I think I would say in general there is certainly a talent shortage. So before doing Kipu, I was also at BASF, and I think we were very happy to building a very, very strong team for quantum computing at BASF. But I think from the perspective of an industry user, it's actually quite different or quite difficult. It's a different experience, to be sure, because typically blue chip companies like BASF are hiring in their core sector, which is in that case chemistry. Everybody all of the top applicants essentially usually apply, and then the large organizations have the ability to just pick. And I think this is not as easy in technologies like quantum computing. So that is typically requires more care to make sure to identifying the people. I think in the case of Kipu, we have been blessed in a sense with my co-founder Enrique and his extremely strong reputation in the ecosystem. So he is extremely strong, and from an academic background, more than 250, I think, publications under his belt, a lot of Nature papers. So applicants actually flow towards us the same way maybe skilled chemistry applicants flock towards companies like BASF or Bayer. And I think this is something that I'm very, very happy about, that the reputation and the strength of my technical co-founder Kike essentially helps us tremendously in the talent space. And especially, I would say, especially when it comes to quantum physics, which is still the key profile and the key differentiator for value at Kipu Quantum. But I think on general, I know that a lot of companies and also startups are struggling. if they don't have the name brand of Kipu Solano, they may struggle finding and attracting the right kind of talent. So I would say ultimately it's maybe a job of society or governments to assure that more university graduates in quantum sciences actually become available to the job market. Especially as coming back to your previous question, Yasmin, with quantum technology being at the onset of the need, certainly there will also be a strongly growing demand for quantum physicists, not only in startups like Kipu Quantum, but also in other larger organizations. And I think we need to prepare for that.
What I find quite interesting is that Kike has a background or is originally from Latin America and built his career internationally. How does it help to have this kind of diversity now also in the founding team and among the C-level executives? Does this contribute to you finding talent, finding customers?
I'm sure that this is maybe another unfair advantage that Kipu Quantum has versus other players, and I think a lot of that. If you look at Kipu's career, he grew up in Lima in Peru. He made his way to Brazil, doing his master's and PhD thesis, and then coming to Europe essentially with a lot of research stays. I think he probably did research on every single continent. I think even including Australia actually. And I think Kike has a global perspective. He's also has a realistic sound picture of what is going on in China, which oftentimes seems like a black box from the European vantage point. And I think it's extremely helpful having that perspective, just to assure that we have a superior strategy. I hear a lot of conversations out of Europe saying that Europe is extremely strong in the academic arena, and it's just about commercialization. And if we only could do that, then we could essentially rule the world with quantum computing and maybe even other technologies. But I think if you really know what's going on also in other places, you see that, of course, Germany is a leading place for academic research, and Europe also. But the difference between other less developed areas in the world is not that large, and at least not if you compare the lighthouse universities and the leading universities in the quantum space. And I think this grounds us and assures that we are not falling into this complacent attitude of saying, we are so great, we can allow ourselves to just relax and nothing will happen to us. I think it keeps us on our toes to have this really accurate and precise picture. I think on the other side, if you look at our team, we are extremely diverse, not only in the C-suite, but also at large on the company level, especially if you look at nationalities and cultural backgrounds, which I find extremely enriching. I think we have, unfortunately, not enough women in our company, and I think this may be related to the fact that still there are less applicants or less women actually studying quantum physics. But I think we have assembled a great team, and that is something that also differentiates, because we are moving very fast. This also creates friction, but I would say in a positive sense. If you have people that have been socialized in China and India working together with Europeans, and also side by side with people that come from a South American origin. So that creates heat, that creates great ideas, and that creates the speed that we need to keep Kipu Quantum as a leading company and on its toes, actually. And I'm very, very grateful that Kike himself is bringing this element constantly to the table. I think not only by his own personal background, but also by the attitude and his openness to also traveling to places like India, which seem like maybe not the highest priority. But if you look at the availability of talent and also the ambition and the speed at which ecosystems in some of these places are developing, it's extremely impressive, and it assures that we are also keeping the right pace even when working out of Germany.
Thanks a lot, Daniel. Time is nearly up. I want to ask you a last question.
Sure.
Some quantum companies like IonQ became publicly listed, and therefore it's of course interesting to know what your vision for Kipu Quantum is.
Yeah, happy to comment on that. So I think one of the new investors that joined our cap table, DTCF out of Germany, actually asked us to add a statement to our shareholding documents that essentially states that everybody in the shareholder and founder circle agrees that Kipu should strive for an IPO also. So I think in that sense, I already signed in blood that this is the ambition at the end of the day. And I think that this is actually in the books for Kipu. If you think about the fact that in quantum computing there will be a coexistence of different hardware paradigms, which is not going to consolidate that quickly. I think at least not in the next 10, 15 years. So there's a coexistence of different hardware from the end user side. There will still be the necessity to having tailored algorithms a decade from now, I would say, to assure that the maximum potential is extracted from these quantum devices. And also end users will need a Sherpa that provides them with usable solutions, which also comes from this talent shortage I mentioned earlier. I'm assuming that not every quantum user will have the ability to hire 10 quantum experts. So they need somebody like Kipu to assure that there is a broad access and wide access with cutting edge algorithms available. And I think bringing these success factors and the current market together, Kipu is going to have a very bright future. We think that we will play a very strong role in the quantum application space and essentially be the go-to company for many, many years for everybody that wants a high-performance solution on a quantum computer for a dedicated, highly valuable use case.
Yeah, thank you, Daniel, for sharing your vision, and also thank you for joining. And I hope I see everybody in our next episode.
Thanks, Yasmin, and thanks everybody in the audience for tuning in today, and have a great week. Bye-bye.
That was On-Site Insights, a series of podcasts by On-Site Ventures about deep tech and the people behind it. For more information on our portfolio companies and investment strategies, visit our website onsite.vc and follow us on LinkedIn at On-Site Ventures.